Hi everybody. In this video clip, we will continue to work on the same interactive decision tree model we generated in the previous session. So let me go back to the Citrix viewer, and this is where we were. So from here, I will demonstrate how to optimize the complexity of decision trees. So before we exit the interactive decision tree mode, let us first save what we have done so far. We generated a maximal tree, so save it, and we exit it. So once you exit it, you return to this E minor, the menu, and from here we are going to reuse the tree we just saved. So once it's completing closing the interactive decision tree mode, then we're gonna make some changes within the properties panel window of the decision tree node. So now we are going to perform an assessment of the maximal tree on the validation sample, the maximal tree we just created. To use the tree we just created using the interactive decision tree mode, we have to select on the train header, we have to indicate we'd like to use the tree we just frozen. In other words, the tree we just saved. So select yes. Select yes. And we are going to run the decision tree. We haven't run this so far, but by running this, it will produce a diagnostic results of a tree. So you will see not only the tree itself, but also other diagnosis results, such as the plot you saw earlier, the assessment plot. So let us run this and see what sort of a result it provides. Okay, the data source node was rerun, replacement done, data partition sort of checked again, and here's the result. That was quick. So in this the results window, this is the tree we created using the interactive mode. But I'd like to see the subtree assessment plot on which we can see how the misclassification rates or average score error change as the model complexity increases. So to get to that, select View and select Model and select Subtree Assessment Plot. And let me enlarge this a little bit. And I'm gonna change the y-axis from default average score error to misclassification rates, indicating that we're interested in the binary prediction outcome, whether a user is a donor or not. So on this chart, you can clearly see that since this is maximal tree, there is vertical line indicating that 15 leaf tree was selected. But as you see, the red plot assessed on the validation set, it actually reaches the minimal level of misclassification rate, which is the most desirable thing, at around when the number of leaves like 7 or 6. So by looking at this, realize the fact that the current maximal tree is not necessarily the optimal one. I mean, you are not optimizing the complexity level. You should have actually created a tree with a much less leaves. So that is what we are trying to do. But for now, let's keep this, and we're gonna name it as a maximal tree. So exit this subtree assessment plot and exit the results window entirely, and then rename this as maximal tree. Maximal tree. There you go. All right, so we have a maximal tree, and now we are going to prune this maximal tree. So how we prune this? So let's take a look. So I'm gonna drag another decision tree node from the model tab and place it right under maximal tree. And I'm gonna connect data partition to decision tree node and select decision tree, and look at this properties panel window. And the main tree pruning properties are listed under the subtree heading. So let's look for where the subtree heading is. Subtree. There you go. So here's a subtree, and the default method used to prune the maximal tree is assessment. One could have selected others, but basically this is basically specifies how to construct the subtree in terms of selection method. So the assessment option, the smallest subtree with the best assessment value is chosen. So that is, intuitively speaking, that's the best one. And then in terms of assessment measures, currently decision is selected. You could have chosen misclassification rate, but since we haven't specified cost and benefits associated with correct and wrong predictions, selecting misclassification rate as assessment measure or selecting decision as an assessment measure would lead to the same results. So let us, for now, stick to decision as it is. So these are the we didn't make any changes, but keep in mind these are the default options being chosen for us when it comes to the subtree. When it comes to pruning this maximal tree. So let's run this, see what happens. So I'm going to run the second distant tree node. So we are expecting this moment the vertical line indicating the optimal level of complexity might have changed as a result applying this subtree assessment options. The assessment as our method and decision as our assessment measures, and see how that affects our results. Whether still the 15-leaf tree is the optimal, or a tree with the last number of leaves now becomes the optimal. So that's the question we are most interested in. Okay, so let's take a look at the results. And if I maximize the tree window we have, this is the result. It's after we indicated our preference in terms of how we prune a maximal tree, we stated that we want a tree which minimizes misclassification rates. And that resulted in this tree, a tree with how many leaves? 1, 2, 3, 4, and 5. A tree with 5 leaves is chosen as the maximal. As the optimal. So I restore this window, and let's take a look at the model, the subtree assessment plot. And as you expected, now if I change the assessment measure as the right one, misclassification rate, so it clearly displays that a tree with only 5 end leaves can help us achieve our goal, which is minimizing minimizing misclassification rates. So a tree with the 5 leaves is chosen. So I'm going to restore this and exit the results table entirely. And I'm going to bring in our third decision tree, and we're going to select a different assessment measure. Instead of decision, we're going to choose average square error, indicating the fact that our preferred prediction type is exact probability quantity. So let's connect data partition to decision tree node. And within this, under the subtree heading, let's change the assessment measure from decision to average square error. So this is our primary objective of the project, to assess probability of donation. So by selecting this option, you can achieve that goal. So let's run this, see whether it produces the same tree, or it produces a tree with the same number of end leaves as before, or it actually gives us a tree with a different shape or a different number of end leaves. We anticipate the latter. The latter may be the case. As we change the assessment measure, it will likely produce a different tree. Sorry about the background noise. If you hear that, when you work from home, that's what happens. All right, so here's the results. Let's dive into this. Check out the tree first. So the tree, if you remember the previous one, this is similar to previous one, but at the same time, this is different from the previous one. It's similar, it's actually the same in terms of the number of end leaves, 1, 2, 3, 4, 5. But it looks different. So in the previous tree, we didn't have this partitioning, but now, the tree looks more symmetric than before. Let's restore this window and select View, Model, and Subtree Assessment Plot. So when we minimize average square error, it clearly shows it selected a tree with the 5 end leaves, and that's where you can minimize average square error on validation set. Okay, let me exit this and exit this, and in this one, in order to avoid any confusion, I'm going to rename this as we should rename this as probability tree. So probability tree. The reason being is, this one, our main objective is to quantify the exact probability of person making donation. So as opposed to the second one, is the primary goal is to predict whether or not a person will donate. So the objectives differ. So we have created 3 variants of decision trees so far. So let me stop here.